Good morning, everyone. Today we will be looking at a concept in object-oriented programming called composition. So if you think about it broadly, the other concept is called as aggregation. So these are like two variations where we associate two different classes. So that is basically the association that we are going to be talking about. So before we saw inheritance, so we had a base class and then the derived class came off of the base class. So this is what we saw before. Now what we are going to be looking at is composition and aggregation. So these are different kind of relationships between two classes. It is not a parent-child relationship which would make it inheritance, but rather it is going to be a different kind of relationship. So let's think about an example. So if you have a vehicle, the vehicle has a engine, right? So this has a relationship. It's called as composition. So the purpose of the engine is for the vehicle. As soon as the vehicle ceases to exist, the engine is pointless. You at this point you have to forget about like reuse and scrap material and all that. Okay, we are talking about it specifically in terms of any dealership you have or anything like that, where the purpose of the engine is for the specific vehicle. Other than that, there is no purpose. So this kind of has a relationship which is composition. So one class, the purpose of one class dies when the other class object dies. So it will exist only for as long as the vehicle exists. When the vehicle object is destroyed, the engine object associated with that vehicle object will also be destroyed. So that is called as composition. Okay, in terms of aggregation, let's look at the same example. You have vehicle and then you have driver. Vehicle has a driver, right? So in this relationship, even though it is similar, the driver continues to exist independent of the vehicle, because a driver can be a driver for any vehicle. So there is a loose coupling here. So this is what we call as loose coupling. So these are the two kinds. So one is tightly coupled. So this has tight coupling. Okay, this is tight coupling. In this relationship, it has a loose coupling. So driver can exist independently even though the vehicle object is destroyed. Okay, so those are the two kinds of relationships that we are going to try and see how we can implement in C++. Now let's go into REPL. Let's try this example. So let's try an example where we have a college, student, address. So these are three classes. Okay, the college has an address, so the relationship is going to be more of a tight coupling. Okay, without the college, there is no purpose for the address in this particular application. With the student, however, the college will have a student. If the college is destroyed, the student can still exist. So that is a loose coupling. So that's why I have dotted lines here. So let's do this relationship in REPL as a code in C++ and see how that works out. So here's my demo code called composition.c++. So what I have here, just for saving some time, I have a student class here. It has these last name, first name, ID, date of birth, date of admission, and status. So these are also some fields, and I have some properties here, the getters and setters. Then I have two student constructors and an intro method. Then I have another one called address. So this is again straightforward. It has two constructors and a bunch of private member variables and a display method. The third is the college class. So the college class is even more basic. It has a name and email, and then one constructor, and then an intro method with no content in it. And this is on purpose. So if we're just talking about composition, So we want to implement composition in this class. So the college class is going to implement aggregation and composition. Aggregation is going to be through student, and then composition is going to be through address. So the composition is where we are going to be creating the object inside the college class, creating the address object inside the college class. So for example, let us say we want to have the name, email, and address, which is the object, right? All of that information will be fed into the constructor of college, and then the college class will handle calling the constructor of address. Okay, so that, and then if there is an intro method or display method, directly we won't be calling the address, it will happen within the college class. So it will be very transparent to the user, and then the object will be created within. So when the scope of the college object is ending, the scope of the address object will also end with it. So that is what is the first step. So I just want to show you, this is the easier of the two. For aggregation, we have to use pointers because we have to create the object outside of the class and then pass it to the class, and then we should be able to use that passed object and then access the members. So it's a little more complicated, but there is loose coupling, that is the advantage. So let's first do the address. So let's declare address object inside the class. This is the first time we are doing it, right? So we are creating address as an object of the class address. So address is the class here. So you can see street address, city, state, zip code. That is what we are getting from the for address class. So let's think about it right now. So we want the constructor, right? Initially when nothing is fed, let's forget that. Let's create one constructor that takes multiple parameters. So what do we need? We need string name, string email, string, we want street name, string city, string state, string zip code. So these are all the fields we need in order for us to create name, email, and address. Okay. So if this is the constructor, let us look at our address. So you can see on line 68, address constructor is taking state, city, zip, all of those things, right? Street, city, state, zip code, 4 fields. So instead of us worrying about, we don't have to worry about like how the constructor works for address class. We have to just invoke this address. How do we invoke this constructor? We invoke this constructor from this constructor. So we take the college constructor. So when somebody is calling this college constructor and passing all this parameter, we are going to take what we want for college and send the rest happily to address constructor. How do we do that? We put a colon here. Just like how we call the base class, here we will call the address constructor, and then we will pass these guys, the ones that we don't care about, that has to go to address, except we can redefine it. So you cannot have the definition here, you have to take that, you just have to pass the data to that constructor. So those are the 4 ones that go into the constructor. So this is how we call the constructor. So from college constructor, we are calling the address constructor. So this constructor will create that object. So here we'll just write the code for the name and email. The rest will be handled by the address class. Do the same here. Okay, so we have the college class, and inside the college class we have address object, and then in both the constructors we have actually called the object the constructor using the object itself. Now when we go into the intro method, so we will be doing a cout name of college email, now we have to be able to get the address to print. So for that, what we can do is, instead of like actually redoing all this, we can just say address dot display method. We can just call that, and then so we are directly able to call the address object and then call its display method. So that makes life very easy for us. So let's see here, let's go to main and then write code. So college name, email, address, so we have created the college object, and then when we create the college object, it is going to be creating the address inside automatically. So we just say call.intro, so we could produce the data and see if it works. Let's run this code. So you can see name of college, email, and then automatically the address comes, because this address has been set inside the address class. So we are just, so that object, there is no access for us for into that object, right? The college class has it hidden, it is inside. So we don't, as a user, we don't even know the existence of the address object inside the college class. Okay, so that is the beauty of how we do it. But if there are any public methods, we should be able to use it. But the main idea is any creation with regards to this particular object, and when it gets destroyed, it starts with the college class, ends with the college class. That is what composition is all about. If you think about the address that is inside the college and you want to access it outside, what you can do is, right now it's public, so you could make this, sorry, right now it's private, you can make it into public. You could make it as a public field inside college, and then what happens is you should be able to access it here in the main function. But when you access, you will say call dot address dot, and then whatever is public you can use it. Right now display is public. Okay, let's go and add one more method here so I can show you. So let's call this as some validation, void zip code validity check. So maybe this function will check to see if the entered zip code is valid. I mean, we could have made it into a getter and a setter, but I just want to, just to show you how to access, I'm just writing this simple thing. If zip code dot length equal to 5. So normally zip codes are 5 characters in length. So we could just say okay. So now what we can do is we can just call this. First of all, the address has to be public. If it is public, then you have to call it this way. Directly you cannot call the address. You just have to say college.address dot and then the name of the method. So let's run this code now quickly. So any property or getter, setter, anything you have public inside address can be accessed this way, but you have to go through the college object. So you can see here 44145, it says entered zip code is valid. So we are able to access anything inside address, but we cannot control when address gets created or destroyed, because the creation and the destruction is part of the college object. That takes care of it. When the constructor of college is called, the constructor of address is called. So that, and then when the scope of college is over, then the scope of the address will also be over. Okay, so that is it for composition. Now we have to go to aggregation. So let's look at the student class. So this is the student class, just some basic information here. I have a bunch of private fields, I have a couple properties, and then two constructors and an intro method. Now we want to be able to create student to be inside college. So think about it, because this is loosely coupled, what happens is the student object has to be first created. First this has to be created, then it has to be passed to the college, and the college should receive that object. So anytime you write declare an object, the constructor gets called automatically, so we cannot directly do that. So inside college, all we can do is we can create a pointer to student as an object. Okay, so we will just hold the address, and so in that case what happens, nothing gets created, we just wait to receive that data. Okay, so that is where we use pointers. So the way it works is, if we come into college over here, we could just say student star stu. So that is a pointer now. So this pointer is going to wait for somebody to give it the object, so that they can be mapped. So it is going to, it's like a deferred object creation in that sense. Okay, where do we create the student? So here in this main, we are going to be creating the student. We could even do it in the beginning. So student is going to have name, first name, first name, last name, first name, date of birth, date of admission. Date of birth, and then we'll give date of admission. So we created a student object. Now we have to pass this student object to college. So how do we do that? First of all, the college constructor should be able to receive it. Let's see how the constructor looks right now. Right now the constructor is only taking name, email, and address. It is not taking any student information, so we have to update it. Here we have to say we are going to be sending you so we have added one more, right? And then whatever we are getting, we are going to be setting that to stu equal to stud. Okay, so first we created a student object, then we are updating the constructor of the college so that it can accept a student, and it has to be a pointer. So we are not sending the value, we are sending the address, right? So that is what is happening here. So we got student assigned. Now we have to connect the dots. See, it's giving us an error saying, hey, you are missing a parameter. So here we have to be sending the student address of stu. Okay, so now that kind of cements it. Now we are sending the address of stu to college object call, and then we are assigning it to the variable here, student. So that is how we connect it. So there is a deferred object creation here because we use pointer. The object is created outside and the address of that object is passed to this so that it can receive it and use it. So the student object still exists outside of the college object, and their construction and destruction are not dependent of each other. You can see the student got created even before the college was created here. The college object was created. Okay, now the confusion comes as to how do we access any information, like for example student information. What if I want to, like just like how I did address information, how do I display student information? Okay, let us see what information we have in student that we can use. Student has an intro method, and then it has get first name, get last name. Student is a pointer. It is not just any pointer, it is a complicated object pointer. So in order for us to be able to call any method, what we have to do is we have to say stu arrow. So this is how we would access any information. This applies to the get f name, these guys also. Whatever you want to access, as long as it is public, you have to use the arrow, because now it is pointed to an object. So we don't use the dot operator for this one. So now it should show us the student. So you can see here. So what we can do is here we can say a title. So this will give us some breakup there as to what is going on. So here you can see enrolled student information. You can see address for communication. So this is all happening through the college object. Okay, so we didn't explicitly call anything. It is all happening as part of the student object. Now, if you want to be able to access the student from here, the student that is associated with the call, you could do it two ways. You could directly use this to here, okay, that object, or we could just use it through the college. So through college, if you want to do, then you can make this as a public instead of private. And again, you have to use the arrow operator. This is an example. You could just say cout. Like that. So again, the key is that you are saying college object dot to, and then the arrow for get f name. So the dot operator cannot be used here because it is a pointer, and it's a pointer to an object, not just any pointer. So you can see here the first name got displayed here. But in this situation, I don't think there is any reason for us to do it this way. I just wanted to show you that it is even possible to do it that way. So we saw that the student object can exist independent of the college object, and if college gets destroyed, student still exists. But in the case of the address, the way we created it, the creation was managed inside of the constructor of the college. So there is no transparency in terms of we don't look into the hood to see what is happening. So it is a seamless process when it comes to address creation. It is tightly coupled, it is seamless, user doesn't have to worry about it. When it comes to student, there is a lot more freedom for the user to create the object, and because we are deferring the object creation inside the class, we are waiting till the student is ready, and then we are tying them together using the address. That is why we are using pointers. I hope this lesson is useful. So the name is Composition C Okay, I have to change the name. The composition is the name, C++. Yeah, it is correct. Composition C++ is the demo name, and this video will be available for you. So this week we are covering composition and aggregation, and we'll be moving on to static classes and abstract classes next week. Thank you.